This is Mr. Martin. This is the end of the video notes for section. What section was this? Section 5.4. So I just want to make sure that you have the right family tree for your quadrilateral. So we started out with quadrilateral, and then from this we get parallelogram. Okay, so you could draw yourself a little parallelogram here if you want. And then from the parallelogram, if we make one of the angles a right angle, we can get a rectangle. Rectangle. So here's our rectangle. And then again from the parallelogram, if we take a pair of sides that are next to each other and make them congruent to each other, what ends up happening is all the sides become congruent to each other, so we end up with a rhombus. So we'll just pretend that I'm going to draw a rhombus here. Okay, and then if we put these two things together, then we get a square. So the thing that you want to notice about the tree here, square, is that the lower figures have all the properties of the figures above them. So a square has every property of parallelogram, rectangle, and rhombus. Okay, it does not work the other way around though. So when you're doing the true-false questions, you want to think about where is that figure on the family tree and decide if it has the properties of, what makes it that, so what makes it a square, and if it'll have everything, all the properties of the figure above it. So then we have our kite. So we have a pair of disjoint congruent sides. So these are congruent, and then we could rip this figure apart so that we would have the two congruent sides, two pairs of congruent sides together. Okay, which we couldn't really do with any of the other figures. We could do it with a square because they all happen to be congruent, but and we could do it with a rhombus also because all the sides are congruent. But two disjoint pairs, and then finally we have our trapezoid. So we've got our regular trapezoid. So a trapezoid has to have exactly one pair of parallel sides, and then from the trapezoid we can get the isosceles trapezoid. Isosceles trapezoid. A little trouble spelling here. Okay, so the only difference here now is that the legs, which are the non-parallel sides, so make sure you know that. Picture's a little bit off here, but non-parallel sides are congruent. So here's our family tree, and again, the figures that are lower in the tree have all the properties of the figure above them. So let's go on to the true-false here. All trapezoids are parallelogram. This is false. A parallelogram has two pair of opposite sides parallel, and a trapezoid has exactly one. No rectangle is a rhombus. That's false, because if it's a square, it's a rectangle and it's a rhombus. All squares are rectangles. That's true. Square is at the bottom, so it has all the properties of the figures above it. All parallelograms are this should be R quadrilaterals. That's true. All parallelograms have four sides. Some isosceles trapezoid are parallelograms. This is false. For a trapezoid, it has to have exactly one pair of parallel sides, and a parallelogram has two. All rhombuses are squares. That's false. It's only a square if it has a right angle. All squares are rhombuses. This is true. Again, square is below rhombus in the tree, so it's going to be that also. No trapezoid is a rectangle. That's true. If it's a trapezoid, it has to have exactly one pair of parallel sides, and if it's a rectangle, it would have to have two. Some rectangles are parallelograms. I really don't like this question, but um, it's kind of false because all rectangles are parallelograms, not just some of them. And then number 10, all rhombuses are parallelograms. That's true. Rhombus is below parallelogram in the tree, so it would have all those properties. Alright, so as always, write down those questions. I don't get a lot of questions in class, and I know that there's questions floating around out there, so write down your questions and make sure you ask me in class, and we'll see you next time.